Hello, everyone. My name is Braden Howells. I'm in Group 6. This is Geology 109, and today my presentation is going to be on Skyhook technology. Um, First, we're going to talk about how to escape orbit and kind of how rockets work. So I've got a picture of Atlas V here. This is a chemical rocket. Typically, rockets use fuel to propel themselves into space. Um, these launches are expensive, and they require a lot of energy. So most of the rocket here is going to be fuel, and we'll see that as we go to the next slide. You've got a little payload, and then you've got a ton of stuff that is used to chemically propel your rocket. So you can, we're talking about the ratio here of payload to rocket weight. It's not very efficient, and it produces a ton of CO2. Now we've got companies like SpaceX making reusable boosters, which is cool, but it still doesn't overcome the launch aspect that you still have regardless. Um, Now the question that the Skyhook seeks to answer is the middleman. What if there was a way to get from this suborbital trajectory into full orbit without traditional fuel? And so here we have the idea of the skyhook. So bear with me with the graphic. A skyhook is essentially a long tether that would dip down into low orbit to grab something and spin it around and spit it out in high orbit. And so this graphic kind of shows a satellite here with a long tether, and the satellite and the tether are both spinning while orbiting the Earth. And when the tether is in the low position, it connects with a suborbital launch vehicle and takes the cargo or the entire vehicle itself, depending on what kind of skyhook you've got, and flings it around. And when the tether is on the high end, it can release it and launch it into space. And the skyhook, as you see here, it is using spinning and momentum to catch this little red dot and fling it out into space. And so this is a way to uh, avoid traditional chemical methods, save a lot of fuel, and increase your launch frequency. I think the most notable part about it is just that it's reusable. We're going to save a lot by investing in this. But if it's so good, why don't we already have one? Well, there's a few problems with this hypothetical skyhook. The big problem is, I would say, the tensile strength. So you've got a tether, as seen in the visuals, and the tether is really long. And it needs to also be super, super strong because it's spinning really fast when it catches things, which we can overcome, but we can't, catch things really fast unless we do have the tether that's strong enough, as well as long enough. And so to build something like this that's going to stay in orbit while spinning, um, you got to have good materials that you're building with. And so that's the biggest challenge. And the number one candidate, popular idea so far to work as the tether is this thing called a CNT, which stands for carbon nanotube. Okay. And you've got this graphic here kind of shows, ways that carbons are used. That's how diamonds are made. You've got this, which is a sheet of graphene. um, you know, Graphene, if you roll it up into a tube, is basically what our nanotube is. If you stack graphenes, you get graphite, but we're just going to keep them in this one little tube. And you can do a single wall tube, or you can do like multiple miniature tubes inside of that. We're going to see a little bit of those examples. But carbon nanotubes are great because they're really awesome. They're super strong and they make good strand material, but it's just hard to make long strands. And that is because you have to control the entanglement really well. Otherwise, things can break, and you can end up with strands that don't actually hold up against a lot of pressure or force. And the breakthrough that I'm kind of reporting on happened just this last month, July 2025, and a study was done to use mixed carbon sources to create our strands, which will eventually go into our aerogel here, which is kind of like a soft sponge-like structure that will be, kind of spooled or woven into fibers to make CNT fibers. And they're using acetone and ethanol. And the reason why this is such a huge breakthrough is because, previous methods for creating CNT fibers typically yield you micrometer or centimeter range fiber lengths. Whereas this mixed carbon source method with the aerogels can produce kilometer scale fibers. And so this is huge. This is like orders of magnitude larger than what we currently have, which is so awesome. And we're not experiencing any, losses in our tensile strength. We're passing the T1100 benchmark for aerospace use. And this is so cool. And it's based on, aligning and controlling the entanglement of the strands in order to make the fibers. And here's the full graphic for you. So you can see how, acetone, ethanol, using just acetone gives you very high strength, but poor continuity. And using, just ethanol gives you the opposite. You've got kind of a lower strength, but you've got a better, longer fiber, more continuity. But when you use the mixed carbon source with the aerogel, you get this tangle that's more controlled, and it's just more structurally sound, giving you kind of the best of both worlds. You've got high strength and good continuity when you mix, the amount of walls that you're using and the carbon sources, which is so cool. And this sort of idea of making these is also supported by a February 2025 breakthrough. I don't know how much you can see on the top there, but that says fully recyclable carbon nanotube fibers. And this is awesome because we're using let me say this right, chlorosulfonic acid solution in order to take these fibers. This is a single-walled carbon nanotube fiber and a double-walled, and they mix them in this solution, respun them, and then measured the like thermal conductivity, electrical, tensile strength, stuff like that, and checked, is a recycled fiber as good as a fresh, newly made fiber? And the answer was yes. You can see this kind of summary statement here, fully recycled without property degradation, which is incredible. And what this means for us is we can have longer, stronger fibers that are fully recyclable, and that, my friends, is a suitable tether material for our Skyhook, which has so many implications for future. You can just see this graphic here that I pulled from a very interesting YouTube video that talked about how we could use multiple Skyhooks in order to send and receive materials or cargo, payload, whatever you want to call it, to and from other planets. This is going to drastically increase space exploration and technology on other planets. Thank you for listening. I've got my sources here, the two breakthroughs, as well as just some basics on rockets and skyhooks. Thank you.